The massive rocket rumbles, clouds of vapor swirling around its base. The countdown echoes across the complex. There's a blinding flash. The ground trembles as the rocket slowly rises, riding a column of fire and smoke. As it punches through the sound barrier, the rocket arcs towards its target, the moon. Beneath its surface lies an estimated hundreds of billions of dollars in untapped resources, water ice, rare earth elements, and the promise of helium-3. Nations and private companies are scrambling to stake their claim. But will the race to mine the moon unite us in a common purpose? Or are we on a collision course that could extend beyond the boundaries of our planet?
Okay, engine stop. APA at a descent. Mode control both auto, descent engine command override off. Tranquility Base here. The Eagle has landed.
On July 20, 1969, Neil Armstrong took one small step for man, one giant leap for mankind, leaving the first human footprint on the moon. It marked the pinnacle of the Cold War space race between the United States and the Soviet Union. For a brief moment, the world stood united in awe of what humanity had achieved. But after 6 successful Apollo missions, our lunar ambitions waned, and for decades, the moon remained untouched by human hands. Now, a new space race is underway. This time, it's not just about planting flags or proving technological superiority. It's about something far more tangible and potentially far more valuable: lunar resources. Welcome to the era of the lunar gold rush. But what's driving this renewed interest? The answer lies beneath the moon's surface. Recent discoveries have transformed our understanding of lunar resources. In a groundbreaking announcement, NASA confirmed the presence of water ice, not just in permanent shadowed craters at the poles, but also in sunlit areas of the moon.
This is confirmation that confirming that it's water and not hydroxyl, but otherwise similar. And was there confirmation of water in the deep craters?
Water is, of course, essential for human life support in any future lunar base. But it's more than that. Water can be split into hydrogen and oxygen, providing breathable air and, crucially, rocket fuel. The ability to produce fuel on the moon could turn it into a cosmic gas station, dramatically reducing the cost and complexity of deep space missions. Then there's helium-3, an isotope rarely found on Earth but relatively abundant on the moon. The European Space Agency estimates there could be 1 million tons of it on the lunar surface. Why does this matter? Helium-3 is a potential fuel for nuclear fusion reactors, promising a future of clean, nearly limitless energy. A single space shuttle payload of helium-3 could power the entire United States for a year. The moon is also rich in rare earth elements, which are key in everything from smartphones to advanced military equipment. And let's not forget the precious metals, including gold and platinum, that could be mined there. According to NASA's Jet Propulsion Laboratory, the moon holds hundreds of billions of dollars of untapped resources. It's a figure that has governments and private companies salivating at the prospects. Imagine a future where spacecraft don't have to carry all their fuel from Earth, where habitats on Mars are built using materials mined and manufactured on the moon, where the costs of space exploration plummet as we learn to live off the land in our solar system. The race to mine the moon isn't just about making space exploration more feasible. It has far-reaching implications for life on Earth as well. The rare earth elements found there can be used in many of our modern technologies. Neodymium, yttrium, and lanthanum are essential in everything from wind turbines and electric car batteries to military radar systems and medical imaging devices. Currently, the production of these elements is dominated by a few countries, leading to concerns about supply chain vulnerabilities. So, in an ideal world, lunar mining could potentially reduce geopolitical tensions, even though it doesn't feel like it now. This is the promise that's driving the new space race. It's a vision of humanity as a multi-planet species, with the moon as our first stepping stone to the stars. The grand visions of space colonization depicted in films like Interstellar or the lunar base in 2001: A Space Odyssey are no longer distant dreams. We're witnessing the early stages of humanity's expansion into the cosmos, with lunar mining as the first step. As Arthur C. Clarke famously said, "Any sufficiently advanced technology is indistinguishable from magic." Today, we're on the threshold of turning that magic into our everyday reality. The stakes are higher than ever, and the race is only just beginning. But the path to establishing a lunar mining industry is fraught. Let's start with the moon itself, because to call the environment hostile would be an understatement. Temperatures swing to extremes that would make even the harshest deserts on Earth seem hospitable. In the darkness, they plummet to minus 173 degrees Celsius. But when the sun rises, you're looking at 127 degrees Celsius. Uncomfortable, for sure, but also nightmare for equipment design because it causes materials to expand and contract, seals to break, and electronics to fail. Every piece of mining equipment will need to be engineered to withstand these brutal conditions. Then there's the issue of radiation, because without the protective blanket of Earth's atmosphere, the moon is bombarded by cosmic rays and solar radiation, posing a risk to any human operators, but also threatening to destroy sensitive electronic equipment over time. The reduced gravity affects everything from how liquids behave to how dust settles. And speaking of dust, lunar regolith is notoriously abrasive. During the Apollo missions, it wore down spacesuit joints and clogged equipment. For a long-term mining operation, it could be a constant grinding problem, quite literally. And that's all before we get to the legal and ethical aspects of lunar mining. The Outer Space Treaty of 1967 states that the exploration and use of outer space shall be carried out for the benefit and in the interests of all countries and shall be the province of all mankind. It also explicitly forbids any nation from claiming sovereignty over celestial bodies, but it doesn't explicitly prohibit the extraction and use of space resources. Can a private company claim ownership of resources it extracts? If so, under whose jurisdiction? The United States has taken steps to clarify this with the 2015 Commercial Space Launch Competitiveness Act, which allows U.S. citizens to engage in the commercial exploration and exploitation of space resources. But this has not been universally accepted. That's where the Artemis Accords come in, a set of principles for lunar exploration put forth by NASA. As of May 2024, 42 countries have signed on. They attempt to establish safety zones around lunar operations and set guidelines for resource extraction. But China and Russia are yet to sign, threatening to undermine the Accord's effectiveness. So then you've got to ask, what happens when two countries or two companies stake a claim in the same lunar real estate? Without a clear internationally recognized framework, we risk turning the moon into a wild west of competing claims. As we've seen on Earth, mining operations can have devastating ecological impacts. While the moon may not have an ecosystem in the traditional sense, it does have scientific value that could be irreparably damaged by unrestricted mining. Lunar mining operations could destroy sites of immense scientific importance, erasing billions of years of solar system history. There's also the issue of space debris. Increased traffic to and from the moon, along with mining operations on the surface, could generate significant debris both in lunar orbit and on the surface, which could pose a severe hazard to future missions and potentially render certain areas of the moon unusable. And of course, the exclusion of certain countries from lunar projects, whether through legal frameworks like the Artemis Accords or technological barriers to entry, could lead to deep resentments and heightened international tensions. We've already seen hints of this in the rhetoric surrounding lunar exploration. When China and Russia announced their joint International Lunar Research Station, it was widely seen as a direct challenge to NASA's Artemis program. The specter of military conflict over lunar resources, while seeming like science fiction, is taken seriously by defense analysts. The race to mine the moon is not just a test of our technological prowess, but of our ability to cooperate on a global scale, to create and abide by international laws, and to balance our hunger for resources with our responsibility as a collective human race. Can we overcome these hurdles, or will the dark side of lunar mining prove too formidable? Despite the challenges, the race to mine the moon is accelerating at a breakneck pace, and recent years have seen a flurry of successful missions, technological breakthroughs, and ambitious plans. On June 1st, 2024, China's Chang'e 6 made history by successfully landing on the far side of the moon. Once thought impossible due to communication difficulties, the mission showcased China's growing technological prowess, and it advances our understanding of the moon's mysteries. Not to be outdone, India's Chandrayaan-3 mission saw a precise landing near the lunar South Pole, a region believed to be rich in water ice and other valuable resources. This was accomplished on a fraction of the budget of other space powers. Meanwhile, you've got NASA's Artemis program. The successful uncrewed Artemis 1 flight in November 2022 marked a big step towards the agency's goal of establishing a sustainable human presence on the moon. But it's not just national space agencies making waves. More and more, private companies are taking center stage. Take SpaceX, which continues to push the boundaries of what's possible in space travel. The fourth integrated test flight of its massive Starship vehicle, which saw both the upper stage and the Super Heavy booster successfully land, represents a huge leap in spaceflight capabilities. Jeff Bezos' Blue Origin is also making strides, and the company's contract to provide a lunar lander for NASA's Artemis 5 mission shows the growing role of private enterprise in space exploration. As these missions push forward, there's a growing recognition that international collaboration will be crucial for sustainable lunar development. Proposals for global frameworks to manage lunar resources are gaining traction, aiming to balance the interests of spacefaring nations, private companies, and the international community as a whole. The International Space Station has shown how international cooperation can achieve remarkable results in space, and similar models are being considered for lunar exploration. NASA's CLIPS program is a good example of this, partnering with private companies to deliver scientific instruments to the moon. But, of course, not all collaborative efforts are universal. China is looking to establish a permanently crewed base near the lunar South Pole by the 2030s and could become a major force in shaping the future of lunar resource exploitation. These developments are also laying the groundwork for humanity's next giant leap, Mars. NASA sees lunar mining as the main stepping stone for Mars exploration, and the ability to extract water, produce fuel, and use lunar resources could be huge for reducing the cost and complexity of missions. How long before there's a bustling lunar economy with hotels for space tourists, research facilities pushing the boundaries of science, and mining operations extracting precious resources to fuel our expansion into the solar system? With each successful mission, with every technological breakthrough, we inch closer to making these dreams a reality. The race to mine the moon is a catalyst driving us to become a truly spacefaring civilization. The next chapter of human history won't just be written on Earth. Once a distant, unreachable object of wonder, the moon is fast becoming our next home and a launching pad to the stars. Over the next decade, the moon is going to be one of the biggest stories in our lives. Successful lunar mining could usher in an age of abundance, with rare earth elements and precious metals extracted from the moon alleviating resource scarcity on Earth. The economic implications are profound, potentially creating entirely new industries and job markets, both on Earth and in space. It's not too crazy to say that scientific discoveries from mining the moon could revolutionize our understanding of the universe. From unlocking the secrets of the moon's formation to providing a platform for astronomical observations, any bases we build there could accelerate scientific progress in a way we've never seen before. And the technological innovations will have a range of uses back on Earth. Just as the original space race gave us everything from memory foam to satellite television, this new frontier could spawn breakthroughs in energy production, resource management, and environmental protection. But perhaps the most profound impact of the race to mine the moon lies not in the resources or the technologies we might develop, but in its potential to unite humanity in a common purpose. Space exploration has a unique ability to inspire cooperation and bridge divides. We've seen this with the International Space Station, where former Cold War rivals work side by side in the pursuit of scientific knowledge. The Apollo-Soyuz test project in 1975 showed how space could be a realm of cooperation, even at the height of US-Soviet tensions. Now, as we set our sights on lunar mining, we have an opportunity to write a new chapter in human collaboration. The challenges we face, from the harsh lunar environment to the complex legal and ethical questions, are too great for any one nation or company to solve alone. By working together, pooling our resources and expertise, we can achieve far more than we ever could in competition. The race to mine the moon presents us with a choice. We can approach this new frontier with the divisive mindset of the past, or we can seize this opportunity to create a new path of international collaboration. After all, in the words of Apollo 14 astronaut Edgar Mitchell, we're all travelers together on a cosmic journey. Explorers united in our quest to understand and use the wonders of our solar system for the benefit of all.